To provide a demonstration of the important role safety plays in the instrumentation, control and automation industry, we can look at the basic theory behind using an instrument within a hazardous area. A hazardous area is one where flammable gases might be present. Let's consider the fire triangle. For an explosion to occur, we need 3 conditions to be met. Firstly, a fuel source is needed. Secondly, oxygen must be present. And finally, a source of ignition is required. Without any one of these 3 conditions, combustion will not occur. Back to our instrument in a hazardous area. The hazardous area fulfills our first condition of the fire triangle. In our demonstration, the container at the top of the screen contains a flammable gas. When we mix oxygen into this atmosphere, we create a dangerous situation by supplying the second condition of our fire triangle. The alarm sound is an indication that we have sufficient fuel and oxygen for combustion. A spark is an example of the third and final condition of our fire triangle, a source of ignition. However, our Bell circuit incorporates electronics which have been designed to limit the amount of energy in the spark and therefore will not let combustion occur in the hazardous atmosphere. As you could see, a small spark was generated, but still we had no combustion. Here's what happens when we remove the energy-limiting electronics from our Bell circuit. In the next example, we'll look at one of the various types of hazardous area instrument enclosures. This particular enclosure is designed to have a flame path where fire is able to travel through if combustion were to occur inside. By travelling through this flame path, the fire should have cooled sufficiently to avoid providing a source of ignition by the time it reaches outside the enclosure. In our demonstration, you can see a small box inside a larger box. This smaller box simulates our instrument enclosure. Once we have a sufficient fuel and oxygen mixture, we create a spark inside the instrument enclosure. You will notice combustion occurs only in the instrument enclosure, and the alfoil lid moves slightly. This proves a pressure wave reached the larger box from inside the smaller box via our flame path. Now, if we alter the gap of our flame path, the fire won't be sufficiently cooled by the time it reaches the larger box. Let's see what happens. You may be asking why this is so important within the instrumentation, control and automation industry. Well, when we are dealing with sometimes thousands of instruments within a facility and a volume of flammable gas or liquid that could supply a city, even a small spark in a hazardous area could be catastrophic.